Hello everyone, I am Edward Pelka, a graduate assistant at Miami University under the supervision of Dr. Clater, where we conducted a study on the comparison of concentric movement velocity with the push band version 2.0 and Vicon motion capture system during resistance exercises. For a brief background, velocity-based resistance exercise training has gained a lot of support recently as a popular method for resistance exercise training to enhance sport performance. The objective of velocity-based training is to detect changes, specifically decreases, in concentric movement velocity, which have been shown to be indicative of acute muscular fatigue. However, the biggest issue we face with velocity-based training is determining an appropriate assessment technology for widespread use, as many studies that use velocity-based training, their gold standard devices used are linear transducers, motion capture systems, which have been shown to be valid and reliable, but are cumbersome and expensive, thus impractical for team-based training. From this, we need a cheap, easy-to-use device that can be used for widespread use for velocity-based training. And this is where the push band version 2.0 comes in. The push band version 2.0 is a 6-axis inertial sensor that provides concentric movement velocity feedback in real time on a rep-by-rep basis. Push collects data at 1000 Hz and sends this information via Bluetooth to corresponding iOS devices on a push portal to provide data in real time, and this data can then be stored for long-term training, monitoring, and interpretation. However, there is little agreement in the literature on the reliability and the validity of the push band. To our knowledge, 4 published studies have assessed push band version 2.0 during the back squat, with none of these studies using a motion capture as their gold standard device, while 5 published studies have assessed the push band version 2.0 during the bench press. Only one of these have used the motion capture as their gold standard device. The primary purpose of this study was to compare measures of concentric movement velocity between the push band version 2.0 and the Vicon motion capture system during the squat and the bench press. A secondary purpose was to determine which push placement site provided the most similar measures of concentric movement velocity when compared to the Vicon motion capture system. For this study, the Pelka motion capture was designated as the criterion measurement system. This was performed by using 12 experienced resistance-trained males from Division I collegiate football and powerlifting teams who volunteered to participate in this study. Subjects were randomly assigned to perform either the bench press or the squat first, which were performed in a 2-dimensional Smith machine which moved in the vertical and the horizontal axis. Push bands were then attached to the right side of the barbell, center barbell, the left side of the barbell, and the right arm of each subject. Vicon motion capture reflective markers were then placed on top of each push band. Prior to resistance exercise trials, subjects performed a standardized warm-up of cycling for 5 minutes, followed by a personalized warm-up. Subjects then performed 10 repetitions at 50% and 6 repetitions at 75% of a self-reported 1-rep max. The push band version 2.0 concentric movement velocity was recorded and stored on individual iPads, while data from the Vicon motion capture markers were recorded, stored, and exported to Microsoft Excel for analysis. Only the concentric phase for each repetition was used for analysis. The Vicon motion capture concentric phase was defined as the time difference from the first positive vertical velocity to the first negative velocity. Concentric movement velocity was calculated as the average velocity in the concentric phase for each repetition. Table 1 here shows the physical characteristics of our subjects, with the average age being 26 years old and the average resistance exercise experience being about 10.5 years. Table 2 here shows the measures of accuracy and bias between the push and the motion capture. Now, I understand there is a lot going on in this table, so I'm going to try my best to make it as easy to follow and understand as possible. So if I will direct you all the way to the left side of the table, we have the different resistance exercises, indicating the bench press and the squat. The next column is intensity, with the 50% and the 75% intensity, followed by position. We have the arm, center barbell, left barbell, right barbell. From here, we can pinpoint any position used, the intensity, and the resistance exercise to determine how accurate the push band was. For reliability, Interclass correlations were used, and those ranged from 0.671 on the right barbell all the way to 0.961 for the arm location. Error was measured with mean absolute error, with this ranged from 0.108 from the left barbell all the way to 0.037 for the arm. We then have accuracy. Accuracy ranged from 84.8% for the left barbell all the way to 93.9% for the center barbell. And this was actually closely followed behind by the arm location at 93.8%. We then have bias. Bias was measured with mean error, which ranged from 0.068 for the right barbell location all the way to negative 0.002 also for the right barbell location. Now, tracking signal is a measure of systematic bias, which I will show you with this table right here as a better visual representation. Tracking signal is a measure of systematic bias, meaning does the push always overestimate or always underestimate the vicon. Figure 1 here represents a specific set for the squat at 50% intensity for an individual subject. Since subjects performed 10 repetitions at the 50% intensity, if systematic bias was indicated, there would be a plus 10 tracking signal, meaning the push always overestimated the vicon, or there would be a negative 10 tracking signal, meaning the push always underestimated the vicon for each repetition. At the 75% intensity, since subjects performed 6 repetitions, there would be a plus 6 tracking signal, meaning the push always overestimated the vicon for those 6 repetitions, or negative 6, meaning they always underestimated. For this set, looking at repetition number 1, the push overestimated the vicon, giving it a plus 1 tracking signal. The second repetition, again, the push overestimated the vicon, giving it a plus 2 tracking signal. But when moving forward to repetition number 3, the push underestimated the vicon, giving it a plus 1 repetition. When you follow the entire set, there was a plus 4 tracking signal, meaning that since it was not plus 10 or negative 10, systematic bias was not indicated because the push did not always overestimate or underestimate the vicon. It would jump between overestimating and underestimating it. In terms of discussion, during the squat and bench press resistance exercise, push provided an accurate and reliable measurement of concentric movement velocity when compared to the vicon motion capture system. However, our data is not in complete agreement with other previous studies reported in the literature, which is likely a function of the measurement methodologies used. We used a 10-camera vicon motion capture system with optical markers being placed directly on top of each push device. Previous studies that used similar methodologies as ours concluded similar results, indicating that the push was accurate and reliable. However, previous studies that have compared push to a linear transducer could not make the same type of measurement comparison. As for those studies, the push was placed on the subject's arm, with the linear transducer being placed on the outside of the barbell. Our data suggest when comparing the vicon to the push at the same location, there is an accurate and reliable measurement of concentric movement velocity. However, since we used 4 push and 4 vicon locations, when comparing the different locations from one another, for example, when comparing the vicon left barbell to the vicon arm, vicon center barbell, vicon right barbell, as the same for the push locations, concentric movement velocity was significantly different at each location, thus indicating why there could be some discrepancy in the literature as to if the criterion measurement system is not placed directly on the push band, the concentric movement velocities could be different at different locations. In conclusion, there were no overall statistical significant differences between the push bands and the motion capture system for concentric movement velocity as a function of position, resistance exercise, intensity, or repetition. However, interclass correlations and mean absolute error suggest that the push band arm location provided the most accurate measure of concentric movement velocity for the squat and the bench, which was closely followed by the center barbell location. Overall, this data suggests the push delivers an accurate and reliable measurement of concentric movement velocity during the squat and the bench press. If you have any questions, please feel free to email me. My email is down below in the right-hand corner, which is pelkaez@miamioh.edu, and thank you.